I'm audible.
Yes, sir.
Okay, in the last class, we have started discussing about how the 7-segment display system can be interfaced to the microcontrollers. Even if you look at today, the number of products, whatever the embedded products available in the market, they generally provide 7-segment display as one of their output devices. The advantage of 7-segment display is for a long distance, even at least on 5 to 10 meters of long distance, it is bright enough to display certain values. In a lot of industrial applications, along with an LCD, they also give a 7-segment display because it's easy to look at and conceive the numbers. Many times in industries, we use the numbers for indicating certain actions. Number changing 3, 4, or operator can set a particular number. So it's easy to add 7-segment display along with an LCD. So that 7-segment display will be the de facto standard when you want to see certain things from a long distance. So that's why whenever you build any project, always recommending a standard hardware interface and standard program, irrespective of the microcontroller you use. So then it will be what will happen, the 10% of the project is done for you. So today we are building such an industrial interface. So this interface, the type of interface what we indicated in this material and the program what we are writing is not there in the textbooks. We have tried this in so many other products, industrial products. So we have followed the same method. Whatever the method we have followed in the industrial products, the interfacing and the program, same thing we have included for your material also. So this only the cost is the extra space and the cost of the shift register is only then some little burden or the drawback of this method. But since the shift registers are very cheaper, maybe around 7 to 8 rupees SMD chip, and also it occupies a very less space. So we are just going with this method because it gives a lot of comfort to the programmer. Programmer need not worry. He can just push the data through a program and he can just do other works. So that's why we have chosen this method of interfacing display. The beauty of this method is you can add the number of digits extensively. For example, your application requires 10 digits. No much changes in the interfacing concept. Just keep on adding shift registers, cascade them, so and add few more digits how many required. If I don't want 5, I require only 3. Again, the same method. Remove the shift register, retain only 3. In the program also, it's very simple to manipulate. So that's why. So this method is being chosen to design 7-segment display in our project. Now, as I've already explained in the last class, I just brief it. So the element for this system is I have used 744094. So 744094 is a CMOS based shift register. It is called a serial in parallel out shift register. So this shift register will have one serial input that is called as data. Whenever you want to push the data serial in, always a clock is a reference is required. Without the clock, you cannot push the serial data into any chips. So generally, whenever we push the serial data, you require a clock as a reference because clock defines what is the time period of one data bit. One clock pulse means, so whatever you provide at that time, the data at this pin will be considered as what? One data bit. So every clock pulse defines the time period of one data bit. That is why clock is considered as a reference when you want to push the data into any serial fashion through a serial fashion method. Now, after pushing 8 data bits through 8 clock pulses, now the data is available at the output of the shift register. But output still it's not available. It is present inside. It is you push the data. It is stored inside, but it is not copied back to the pins. So this method is provided so that glittering, that because when you push, so some glittering effect will happen because you're pushing the data. Immediately what will happen, that effect you can see on the shift register. Since you're pushing so fast, it will not have any effect, but it's always better to make sure that after complete pushing the data is over, then copy the data to the output in a single shot. Then it's a better option. That is why most of the shift registers, the latest what used in the industries, they have what is called as latch inside. 8-bit latch will be there. So first you push the 8-bit data, then after pushing the data is over, then I copy the 8-bit to the internal latch. How do I copy? I require, again, a pin is required to initiate this action. That pin is called a strobe. So whenever I make the strobe pin high, the data what is there in the shift register, that is in the flip-flops, will be copied to the internal latch. Then I'll make the strobe low. So how do you push the data? Every data clock pulse will be using it. How do you generate a clock pulse? It is a low to high. This pin, what is required? You have to make it low and then high. One time if you make it, that is nothing but one clock pulse. You can able to do it. Then after pushing this data and the data is available here, immediately the 7 segment copies the data and displays the segment here. So when 1 byte of data is being pushed here, yes or no, then what we do, we push other byte of data, that is another digit. So whenever you push the next digit, what will happen? The digit which is already there here, it will always move to what? Next location, it will move to here. So the concept of the program, what we're supposed to write now is, we should be able to understand that. So whenever we push the data 1 digit and we push the next 1 digit of data, so what will happen is, whatever the data you displayed here will be moved to what? Here. So then if you push next another digit, what will happen? Whatever the data you have displayed here, it has been pushed to what? Next digit. So this will continue like this for all the 5 digits. So I have to push 1 digit at a time. So how many times I have to push? 5 times I have to push, so that whatever the digit, if I want to display 1, 2, 3, 4, 5, first I have to push what? 1, then second I have to push 2, 3, 4, 5. So that is the order I have to be able to push it. So now we will develop a program. It's called as a device driver program. So whenever in embedded system at the low level, you write important code, the code like this, pushing the data into shift registers, putting the displays, called as a basically device driver program. So these are the device driver programs which are available for an operating system to invoke to get the work done through your application calls. So if you see any other device driver program, this type of small codes will be present inside that one. So now we'll be writing a driver code. What is a driver code? Driver code which drives this 7 segment display. So we will break the problem of this into very small things. Now, what is the logic required to push 8 bit of data into one shift register? That is a basic problem for me. Smallest block of code is this one. How do we develop that code? We will only look into this logic now. So to do that one, I should be able to understand now what are the pins I have used to push the data into a shift register. So 3 pins are used. One is the data, clock, and the strobe. So we will assume certain pins for this and this and this. Now we will see that. So the code only required to push the data into this one. Keep thinking about how we could have done it. So keep thinking in your mind. So I will just explain that logic. So I'll remove all of the things. So keep thinking in your mind how we can push 8 bit of data which is there in the program in a variable, so into that one. Okay, so now look at that. My program is a standard code, whatever I said. A delay program is there. One LED is connected to P0.31 always. I just make the LED on to indicate it's working or not. So this is now for this project it's not required. Now I'll start only copying what portion required for the 7 segment display. So look only that portion, don't look at anything else now. So now what I'm going to do now certain logic. I'm going to do certain logic which is required and essential to implement certain logic here. Now, so before I start doing this one, I will use what is the registers required for this one, for connecting to the shift register. So what are the required? I require 3 pins we have used in the project. So those pins are, I'll just give it in a comment lines to start with. So what are the pins I've used it? So I've used P0.19 for the data pin, P0.20 for the clock pin, P0.30 for the strobe pin. These are the 3 pins I'm using to push or to interface the 7 segment digit to my system. So what is the first thing I have to do it? I have to make these 3 pins as an output pin. So I will make those 3 pins as an output pin. So I will copy only that portion, what is required for that. Now keep looking at this here. Now what I have done, so I have added now what I have made, since I've used 19, 20 and the 30 of the port 0 pin. So I am using those pins as an output pins from the microcontroller. I made the direction as what? 1. So that is output. The direction is being now configured as a output. Now I required a logic. Now I required, what is the logic required? To push 1 byte of data into the microcontroller, into the 7 segment display. Now, So only look at that code now for a moment. Only look at that code, what is required for that. Now, what are the things required? You have what is called as one number. Let's say some number is available. So that number, let's assume that it's available in a variable called in one variable. So let's say it's available in a variable called segment 7 data. I'll use the same variable names, segment 7 underscore data. Let's say some variable I'm using it. This data contains, segment 7 data contains the number, the code which is to be displayed on that. For example, so let's assume that it has contains a code for displaying, let's say 1. So 1 means, so the B and C segment should be 0, 0, other things. That is nothing but it is 0x. So 9, F9, let's say this is a code. Now, let's say segment 7 data is one variable. It's a one variable. I'll declare as unsigned character. So what is this code? So this code is nothing but 7 segment code for displaying the, let's say number 1. I've taken it. Now I have to develop a logic here which will push this data into the first shift register. Now what is required? I have to require and understand few things. What are the few things I have to understand? If the data, that is F9, if I write in the binary fashion, it is like this. It is like this. Now, whether you want to push this data into the shift register serially, so how many bits are required? 8 bits are there in a byte. I have to start pushing either from I have to push from. So this is the D7 bit. This will be the D7 bit. The first bit will be this is the D0 bit. So which one I am going to push first? Either should I start pushing from the D7 bit, I have to push into the shift register, or I have to start pushing from the D0 bit. That depends upon how you have made a connection. So now we will, if you look at here connections here, see that the QP0, that is 8 bits of the shift register, 8 outputs are there. The lower bit of the output is connected to what? A. The upper bit or the most significant bit of the output is connected to what? Decimal point. I have connected like that. If I have connected the other way, the shifting would have been different. So you should know that what is the way you connected the outputs of the shift register to the 7 segments of the 7 segment display. Only by knowing this, you can able to push. That means that if I push first the most significant bit, that in the sense, if I start pushing from D7 onwards, then what will happen? After 8 bits of pushing, the D7 will come to this position, the D0 will come to this position. Exactly, it matches the connection whatever you made to the 7 segment display. So that means that this connection, whatever I have made it, so for this connection to work properly, I have to start pushing the data from what? MSP, most significant bit. This you have to make very clear whenever you start developing the projects. What is the order? What is the way you are pushing the data? So now I have decided. What is the way I decided? I have to push my data from most significant bit. Okay. Now the question is, so we are very clear that we are pushing this data. Now, how do you extract one bit of data, that is only D7 bit data, from this byte, that is whichever their segment 7 underscore data, from this variable, that is a 8-bit variable, I want to extract only one bit now. That is which bit I have to extract? D7 bit. In assembly language means we would have as got what is called left shift, right shift is there. So whenever you do the left shift, right shift, it goes to the carry. It's an easy way to shift and use the carry flag. But here we don't have the facility to access the carry flag. So what is the way we have to do it? There are a lot of methods are there. I've used a mask. So mask means, so mask means you make all the bits which I am not interested 0, yes or no, on only retain in this 8-bit number the bit which is of your interest. So for that, what is the operation I'm supposed to do? AND operation. So I'll copy only the statement what I've done it. So now let's say, so now look at this. What is the next statement I'm going to do now? So next statement is what? I am extracting one bit. Which bit? MSB bit from the number. How do you extract? I said masking. How do you do the masking? AND operation and masking I'm doing. What is a mask byte I have prepared? 080 is a mask byte. So because whenever you AND with a 0x80, that means that you are ANDing with what? 100 and then 00. So look at this. whenever I AND this number 8-bit number 80 with this number, what will happen? All the bits D0 to D6 become 0. Only the D7 bit will remain in this operation. That means that overall, when I perform this operation, the total right side argument depends upon what? Depends upon the D7 bit. If the D7 bit is 1, that means the total value right side is nothing but what? It becomes a positive number. It's a non-zero number. We are interested non-zero. By chance, if the D7 bit is 0, then what will happen? The total right side of this equation, it becomes what? 0. That means that by doing this operation masking with an AND operation, then what will happen? Either the total value becomes what? 0 or non-zero based on the D7 bit. That is the most significant bit. So now that contains the temp. So what does the temp contains? Temp is only two possibilities there. Either temp can be 0 or temp can be non-zero. Whenever the temp is non-zero, that means that MSB bit is nothing but what? 1. You would have extracted the meaning of the MSB bit. If the temp is 0, that means that MSB bit is what? 0. That I got extracted. Now I have to what? I have to, based on this understanding of the temp, I should be able to push my data. Now what I have to do it? So I have extracted the data. I have extracted the meaning of the MSB bit in the temp variable. Now I have to put my data here. So what does I have to put here? My data I have to put here. What I have to put here? If the temp is non-zero number, I have to put here what? Logic 1 I have to put it. If the temp is 0, I have to put here what? 0 I have to put it here. So that means that I should be able to place the data on this bit. How do you place the data on this bit? We know that it is nothing but P0.19. So P0.19 is the pin number for the data. So on this P0.19, I have to place 1 or 0. So how do you place it? Based on what? The value what is there in the temp. So now I'll take that logic now, only that portion, how to place the data there. So now I will just take only that portion. Now look at this logic now here. So what is I have done? So I have done now, if temp equals to 0x80, yes or no? This is two ways I could able to write in the two ways. So I have written this method. So now I can also, you can do another method. If temp is not equal to, see this, instead of this, I could have written like this. If temp not equal to 0, like this also I could have written it. Or I can also write temp equal to 0x80, because why? Whenever the last bit is 1, after you performing the AND operation, what remains in the temp variable? So what remains in the temp variable? 0x80 remains, because why? All the bits will become 0, you get this value only. So either I can use this method or I can go for this method. Now, if it is a non-zero, what should I do? I should place 1 on the bit. That is which bit? P0.19. So how do you place it? Using a set register. Use the set register. Now prepare a 32-bit pattern such that only what? The 19 bit becomes 1 and then write into this one. So whenever you are writing into set register, R is not required. Actually, you can remove that. It's not required because you can directly write in set register. Only that bit is become 1. So no other bits will be modified. Only in case of a direction, you can use R. In case of set notes of the manual, R is there. You can remove that. Without that also it works. So now what will happen? You are making the 19th bit. 19th pin is equal to 1. So this you can use this method, or you can also write like this also. Pattern also you can able to write it. So I'll remove this pattern. So it's not required. So to avoid confusion. So now, if by chance the temp is equal to 0, then what will do? I will make that 19 pin is equal to 0. So I'm preparing a 32-bit pattern where the 19 bit is equal to 1. I'm writing that into clear register. My job is done. So what is the first job? So first job is extracting the MSB bit of an 8-bit number, placing that bit on the pin what is required. This is a fundamental core principle of the driver logic. In most of the time, driver logic, how do you develop? The data what you have in the memory is what? In bytes. But the way you have to communicate to the devices is what? In bits. So whether it's a ports, whether it's a serial ports, parallel ports, you have to push, you have to handle the bit-wise, yes or no? So I had the 8-bit data, I'm able to extract a bit and place it or put it to the hardware wherever required. I've done it. Now, the moment you place the data 1 or 0 here, does it go inside? Does it go inside? No. This shift register does not know that whether you place 1 or 0, because how does it know that whether you place Whether you place 1 or 0, some data will always be here. So there is no way for the shift register to know that you place the data. So what is the way to indicate to the shift register that is you place the data, please take the data? Clock is a method. So what is the way? I can generate clock pulse like this. One, I can generate it. I can this method. This is called as positive edge clock signal. Positive edge clock signal. So what is a positive edge clock signal? I have to apply on this clock line. That is a single pin P0.20. So I have to first what? Place a 0 logic 0 here. Yes or no? Then give some delay and then make it what? 1 you have to make it. Many times what will happen is either you can give a delay. Even if you don't give a delay, since the microcontroller takes some time to time for placing it and making it 1, that itself is sufficient. So it depends upon the speed at which the shift registers work, speed at which the microcontroller works. You should take a decision how much time you have to give a delay is required or not. So now how do you generate a clock pulse? So first of all, check in the data sheet of the shift register whether it's a clock pulse is a positive edge triggered or is a negative edge. That you have to find out from the data sheet. If it is a positive edge, then what you have to do? You have to create the edge at this point. How do you create edge at this point? Make it 0 and then make it what? 1 you can do it. There is another method is there. Instead of making 0 to 1, what you can make it? You can apply 1 here and make it 0. That means that always before entering into this program, keep the clock line 0. Keep the clock line 0. Then in such cases, what will happen? You apply the clock. Since we know that in the beginning, by default, the clock line is 0. So immediately what will happen? You can apply 1. So what you can do? Immediately what? You can apply 1. Because why? We know that previous to this program, clock is always 0. We can make an assumption. We can keep the clock line 0. Make it 1. Then what will happen? Keep it for some time for delay. What is required for that? Then make it low and leave the program. So this also you can do. This is also equivalent to what? Transition. You're preparing a transition. But always we are assuming what? This clock is always at the low. Yes or no? So whenever you push the data, make it high, push the data and make it low. So always since the clock is low, yes or no? So you can directly apply 1 and then you make it 0. So this is the method we are following in this program. So now I will be generating a clock pulse through the program. So now I'll copy only the clock pulse logic, sending 1 clock pulse and put the data into that. So now I will copy the code for the clock pulse. Now what is this clock pulse? So as I said, I'm assuming the clock is already 0 before entering the program. I'm just applying the 1. I'm giving a delay of 1 millisecond and then making it, so again 0. See, look at here. P0.20 is the pin we have used. P0.20 is the pin we have used. So for generating a clock pulse, I'm making it 1. So that is a logic here. I'm making it 1. Then I am making the 1 and keeping it for 1 millisecond. This time period can be required or not required, or it may be more, depends upon what? The data sheet and the speed at which the shift register works. Nowadays, shift register works at 50 megahertz. That means that LPC2148 also works at 50 megahertz. So in such cases, it's good enough, even if you don't give a delay. But if the shift register works at 10 megahertz or 8 megahertz, then your controller works at a 60 megahertz. Then what is required? Your delay is required. So always, these are the concepts you have to understand in the interfacing. Many times what will happen? The same logic you apply there, same program you apply to another microcontroller, it's not working. It was working with this microcontroller. What is the challenge? You should be able to understand the speed of the peripheral, speed of the microcontroller. That is why the embedded systems, one characteristic of the embedded system is called as multi-rate systems. Unless like a desktop systems, embedded systems are called as a multi-rate system, because different logic, different peripherals work at different speeds. Your program should be able to handle different peripherals working at different speed. So these delays are very crucial to make sure that provide that what is the interfacing required to handle the shift register. So these are the very crucial values. If you don't give it, so many of the projects will not work in some microcontrollers. So if you're giving proper delays, will make it work. So that is why when you're working in a hardware level, you should be very clear that so the speed of the peripheral should be known before writing the programs. Now, so then after making it 1, after keeping it for high for some time, again I make the, so this clear pin is equal to low. That means that P0.20 is low. So now I have achieved. So what is this I have achieved? I have generated 1 clock pulse here. What is this I have done? I have placed the data, that is one bit of the 8-bit data on the data pin. Now it is done. Now how many times I have to repeat this one? I have to repeat this 8 times, because why? The data, whatever I have taken segment 7 data, see that how many bits are there? there are 8 bits are there. Now what I have done? I finished only one. So I have to complete what? 8 times I have to repeat this one. So now before I put this in a loop, so what should I do it? What is the thing I have to do it? Since first time you extracted the last bit. Now before I repeat this one, I have to make one statement here. What is the statement? So the statement here is required what? So get the next bit. So get the next bit, because why? First time you extracted the MSB bit, D7 bit. Now you have to send what? D6 bit. So that means that, so before you continue the same logic, bring the D6 bit to what position? D7 position you have to bit it. Because why? You are always extracting what? The last bit here. You are always ANDing this data and checking the last bit here. So this, since one bit is completed, now before repeating the logic, I had to bring what? D6 to what? D7 position I have to do it. That means that every time I repeat this logic, you have to shift that one. So now I'll get to the next bit. So what I'll do is, so I'll perform the shift operation and get that number here. Now look at here. So now what I have done here? Now the segment 7 data, which contains the number, I have to get the D6 bit to the D7 bit position. So I have shifted this number left shift by 1. So that means that, so now D6 will come to the D7 position. Next time when you repeat the loop, what will happen? D5 will come, D3 will come, like that, D0 will come. Like that, every 1 bit you are extracting from the 8 bit and you are pushing the data. And this has to be repeated how many times? So 8 times you have to repeat that. So I will just take the for loop for that. So now I will write the for loop. I'll put this in a for loop. So now if you look at that, I have placed whole of the for loop and this placed here. So now look at this logic. So this is the core logic for this program. This is one of the very important device driver program, so which gives you a lot of information. This is not the simple program. It may appear simple, but a lot of concepts here, because you're converting byte into bits and you're implementing a serial protocol on your own, both at the hardware and software level. So how does the mouse communicate with your system? How does the keyboard communicate to your system? How does the network will work? That is, Ethernet cable will work. How does the wireless system work? Inside, they have got this type of code will be there to push the data, byte data into bit data and send at a particular speed here. Now here the speed, what is the speed? I am not dictating a speed, because why? Only speed I'm considering is what? The delay is the only speed factor I'm taking into consideration. So the whole program is, the speed control of the whole program is done by what? The delay. That means that this loop repeatedly works at what speed? 60 megahertz. That is CPU clock speed. At what is the speed breaker for this? Delay MS is a speed breaker for that. That means that by introducing this delay properly and making this program work at 60 megahertz with with approximately around 20 to 30 megahertz shift register, you are able to push this data. So this is how you're implementing a serial protocol. So what is a serial protocol? You're taking 1 byte of data, so and converting it into bits of data and push into that one. So once this is done, your major one of the job is done here. So now if I want to push 5 digits of data, then what should I do it? The whole program I have to put what? The same program, I have to put them in a loop for 5 times. Every time what you have to change? The segment 7 data, I have to change it now. So instead of making a hard-coded data, now I'll change this one. So what I'll do is, I'll put another for loop now. I will put another for loop now. So I'll put another for loop. I'm audible. I'm audible.
Yes, sir.
Okay. So now I put another for loop. Since this 5 digits are there in my 7 segment display, I'm just I'll just pushing this data 5 times. But each time, so what is the one which has to change? The segment 7 data, whatever you take and know, this data to be given properly. So first time you give what? First digit, that is in the sense last digit to be. So I have to put it here what? Before the inner for loop, I have to put this data here properly. Now, so what is the digit you have to push first? As I said, the last digit to be displayed, you have to push first and then the second digit like that. So what we can do is, we can put this in array. So in a characters, you can put in a string and then extract 1 by 1 and you can put into this one. So now I'll do the same job. So assume that it's available in the buffer. So I will take the data, I'll put it here now. So what is this logic? I'll explain it. So I'll just put the data here. So now look at this here. Now I have done some logic here. I've just given here. So basically, so I suppose there is an array is there. There is an array. Don't look at the get alpha code. I'll remove the get alpha code for a moment. So see that. Now what is I'm doing? There is an array is there. In the array, what is an array? It's an array of unsigned characters. There I have placed all the codes which is to be displayed in the 7-segment digit. So what is the name of the array? Buff. Maybe I can declare like this. So I can declare an array like this. So I would have declared, so buff. So how many digits are required? 5. I would have declared like this. So what I'm taking, since I have to extract first what? So the first digit. So buff plus I've just taken the first one. So then what I'll do is then I is equal to 1. Then I'll extract the second digit. Like that, I'll continue this one. So since buff is a pointer, to extract any information from an array, what we do? So we use a pointer. Since it's a pointer, I'll use a star here. So buff plus I. So what does this will give me? It will extract 1 byte or 1 7-segment code from the buff at a time and place it in the segment 7 data 8-bit variable. Then use this driver logic to push the data here. Now after you execute this for loop, then what will happen? The whole 5 digits will be displayed on the 7-segment display. Now only question is now you have to place in this buffer the 7-segment codes. You have to place it. What is the logic? We have seen that one technique of what we have got is, so one of the method to convert actual characters to be displayed or actual numbers to be displayed into 7-segment code is what? Lookup tables, that we have seen in the last class. Lookup table is what? Prepare the 7-segment codes, keep it an array, then index into the table based on the number, whatever you want to get the 7-segment code or what you want to display, and then you can extract it. That is one method. Now I'm showing the second method of converting the number or alphabets which you want to display into 7-segment codes. So this also, it's a programming technique. It's a beautiful technique. So now for a time being, I'll stop this code here. Now I'll go to another logic. What is this logic? So look at this logic for a moment. Look at this logic for a moment now. So now I will copy this logic here for a moment. So look at this logic for a moment now. So what is this logic? This is exactly lookup table. It performs the job of a lookup table. Now, what is the name of the function I given? Get alpha code is the name of the function I given it. This is exactly the function implement as a lookup table. Now, what I have to do it here, all the 7-segment codes which are required for the different numbers and the alphabets, I'll be storing here using the different case statements. For example, I want the alphabet, the 7-segment code for the displaying F. So I'm displaying in this program, I'm displaying instead of numbers, I'm displaying the fire and help alternately. So that means I've written a program to display what? String. What is the string? Fire, and the other string is what? Help. So fire and help, these are the alphabets. We can approximately, we're nearby, we can able to display in the 7-segment digit. So see that P I can display, L I can display, H I can do it, E I can do it. R is a little challenge, but you can do it. I can do it. I is nothing but 1, like that I can do it. F we can display. So these are the different alphabets I can display in the 7-segment code. So on the 7-segment display, to display these digits, these alphabets, what should I do? I should require a 7-segment code. So I prepared a 7-segment code. So what is the 7-segment code for this F? 80. What is 7-segment code for the space? That is no display. It's an FF. That is all the segments are off of. So like that, I've prepared in the case statements. Now, whenever I want to display any of the character, that is alphabet or a number, only what should I do it? Make sure that that is there in the case statement that you should able to, you should prepare. If it's not there, you should add that case statement. Then I'll call the get alpha code. Whenever I call the get alpha code, I'll pass what is the decimal digit or an alphabet. Basically, whether it is a number or alphabet, basically they are represented by what? ASCII codes inside the program. So that ASCII code of the character or the alphabet, I'll be passing to this function. The moment you pass this one, it will matches to one of the case statements and return that value here. So this is what I have done it. So if it does not match, it will display what? FF. FF means what? No display in the 7-segment digit. So this exactly functions like your lookup table. So this is one of the technique we have used in some of the projects. So I've just given the same thing. So get alpha code is the lookup table to convert any ASCII code into a 7-segment code. So now what I've done, so using this function, now I'll call this get alpha code function. Now I'm calling this get alpha code function here. So what I've done here, I have called that function get alpha code function. Now see that my program is ready. So what is this program? Whenever you call this program, so this will display 5 digits. This will display 5-digit characters. It's a 5-digit on the 7-segment display. This can be, the 5 digits can be alphabets also, can be number also. This is the function what we have implemented. Now once you have understood this program, now what I'll do is I have enclosed whole of this logic into one code, one function. The name of the function is called as alpha display 7-segment. This is a program I have called it. I'm just calling this program as this one. You can just look at this for a moment. So alpha display 7-segment is a function I have written it to display one string on the 5-digit display. So whatever the string you want to display or whatever the numbers you want to display, only requirement is place it in array of five characters or array of 5 unsigned characters and then call this function. When you call this function, this automatically push that 5 characters or the 5 digits of a number on the display. So it requires one more function called as get alpha code. So now I'll just put this logic here and make you run the program one time. So I will just remove the whole of this code. I'll copy the whole logic here. So whole program is there. So I'll remove everything. Now look at the whole program. I written the whole program. So I'll just brief from the beginning once. So these are the two functions I've explained. You know, get alpha code as a lookup table. Alpha display 7-segment is a function which can display the 5-character string or a 5-character. So which can contain the number, and the delay is a function which is for implementing 1 millisecond. That is, the value indicates how many milliseconds of delay you require. These are the two functions they explained. Look at the main program. Main program is so simple. So I have just given the function function definitions. Sorry, function declaration prototypes I have given here. So whenever in the kill, whenever you give the definition below the main function, give the declaration here. So you know the definition is nothing but implementation of the code. So declaration is only indicating, so what is the argument you're passing for the function, what is the return type. So now this is a main program. So what the main program, I'm just doing it. I'll just call the first one. Even I've just indicated inside here only fire. This is the fire is nothing but, so is I want to display fire on that one. So if you want to remove this warning, I can always make it what? I can just say character star and typecast it. I can do it. So that will go if required. Otherwise, nothing not required here. So just to remove this warning. Okay. Okay. So okay. So I call the first function. It displays what? The fire. So then I'll give certain delay. Now I made the comment here to show you on the simulator. Actually, when you're running on the system board, you give some delay of half a second so that you can able to watch the fire on the display. Again, I'm calling that help. I'm giving a half a second. Put this in a loop. So when you run this program, what do you get? You get on the display what? Fire help, like that you will display it. So Monday I will record that video on the kit which is there in the college. I will show you that the actual video for you. I'll display. I'll show you both the kit and the video also. How we can download this program, how we can run this program on the kit. I will demonstrate. I'll set up the camera. I'll show you that one. So this is the program for implementing a string display, alternate string display on the 7-segment display. I'll just compile. Only we can observe to some very basics in the simulator because you cannot see the 7-segment display, but only you can just see that whether the bits are changing or not. So now I'll run this code. So what are the things I can observe in a simulator? I can observe the pins. What are the pins? One logic. Okay, before this, I want to explain one small logic I've missed out. I'll just tell you and then continue this. So as I said, whenever you push the shift register, there is always after pushing 8-bit of data, you have to use what is called a strobe signal. So I was telling you that once you push the data into shift register, the data is not comes to the pins unless what use the strobe signal and transfer the data from the shift register to the internal latch. So that portion in the logic, I'll just explain you once. So when we do that, so when we do it after pushing, see that after pushing 8 bit of data here, yes or no? So that means that I have pushed what 8 bits of data, then I have to send a strobe signal. See here. So what I have done here in this sense here, I have pushed not only 8 bit of data, I have pushed all the 40 bits of data at a time first, because so since it's a 5-digit display, there's no meaning of sending a strobe for every 8 bit of data. Push all the 5 digits, that is 40 bits of data into all the 5 digits. Then once it's a push, then you copy the data from all the shift register into the latches. So then I'm generating a strobe signal. So what is a strobe signal? I said P0.30 is a pin we have used to generate a strobe. For this IC, what is a strobe? You have to make it high for some time and then low. So I'm making the P0.30 high for some time. Then I'm giving a delay for 1 millisecond. Then I'm making this pin is equal to what? Low. So I've just made it low. So this is how I can able to control any pins and implement the timings in my program. So now going back to the program now. So since it's running very fast, so you can just make out some timings here: 16, 17, 18, 19. So these are the pins I've used. 19, 20 is what? 20 I've used for the clock, 19 for the data, 20 clock for the clock, and the 30 for what is called as a strobe. So I can put a logic analyzer. I can display the logic analyzer. So I'll go to the setup. So I'll clear all the signals what is available there. I will add the 3 pins what is required. So port 0.19, then port 0.20, then port 0.30. So I've just indicated, since all they are bits, they are digital bits, I'll change from analog to bit. So this also change from analog to digital bit. I change from analog to digital bit. Now let's say I will set up this one. I'll run the program in a single shot. You can see that. You can see that 19 is the date, clock, because why? Clock is so fast. Yes or no? For every 1 digit, you require 8 clock pulses you to push it. And this is the strobe. So strobe for the one set of data, you're making it. You can just, so you can see that clock pulses and this. And since it's a strobe, and strobe is always high, only for 1 millisecond it comes low and high, you're not able to make out here. But that is why just 1 dot, it will come and here. So you can see that clock is always a higher frequency compared to data. Because why? For every 1 data bit, so how many clock pulses required? 8 clock pulses required. That is why clock frequency is high compared to what? This one. You can see that this is the 7-segment program, where this is a device driver program. So whenever you use a device driver program and implement in hardware, a lot of issues will come. It will not work for the first time. Then you have to use a logic analyzer. How do you use a logic analyzer? We have a logic analyzer in our laboratory. So logic analyzer is an equipment where you can use this equipment in a similar fashion, use the probes and connect to the bits you want to observe on the board. So you can, by observing like this, you can find out, for example, if the clock is not coming, that means that there's a mistake in the program. If the data is not coming, you should check your program. So logic analyzer enables us to track the mistake in the hardware or mistake in the software. You can see that those bits are changing here also. Those bits are changing here, data bits and the clock bits. So this is how the program goes. So if any doubt is there, you can just tell me the doubt. This completes how interfacing 7-segment digits to your systems. So we have understood that what is a 7-segment digit. 7-segment digit will becomes into 2 formats. One is a common anode, other is a common cathode. And each of the 7-segment digit will have 8 pins for the segments and 2 bits and 2 pins of a 7-segment digit is available for what is called 1 pin is available for connecting to the VCC or to the ground. If it's a common anode, you have to connect the common point to what? The plus 5 volts. If it's a common cathode, the common point you have to connect to the ground, and then you have to use it. So if I want to connect one 7-segment digit directly to the LPC2148 microcontroller, I require 8 pins. We can do that method also. So the general method used to convert the one number system, that is a decimal number system or ASCII code, into the 7-segment code is what? Is a lookup tables. We can use it. What is a lookup table? It's an array of the codes. So by using an ASCII code, I can index into the table, I can get that data. How indexing is possible? Because we know that ASCII codes from 0 to 9 is what? In a contiguous way. A to Z is what? Continuous. That is why, since the number system in ASCII code is a continuous, I can use a lookup table concept. So since number of pins required directly to connect is what is always more number of pins is consumed. So we will always use another alternate method of having many number of digits using less number of pins. That is called 7-segment shift register method. We have used it. So we have every one segment, we use one shift register to use as a memory to hold the data. So and give it to the 7-segment digit. By cascading, what will happen? So we can use the common lanes of the microcontroller to push into the whole set of shift registers as a one device. We are treating the 5 shift registers what? One set on one device. So this completes a discussion today. So any doubt is there, you can ask.
So can you explain about the strobe again?
Yeah. So if you look at this figure, I'll just stop for a moment. Okay, I'll just explain. See, if you search in the net, yes or no, if you search
already working in India. Yes, we are women developers across India having 6 months plus experience.
Okay. Okay. So going back to the 744094 shift register, it has got a 3 components inside one. One is called as 8 flip-flops connected in serial, which is acting like a shift register. Then 8 flip-flops, that is output of 8 flip-flops, are connected to one latch. So inside what is called as internal latch. What is a latch? Latch is nothing but a memory element. Whenever you push some data into the latch, it will hold it until you push the new data. The third component in the shift register is called as tri-state buffers, tri-state buffer. In this mode of configuration, always buffer is enabled now. So forget about the buffer, because buffers is always enabled here. In the sense, whatever the outputs of the latch is always coming to the pins directly now here. Whenever you push the data, what will happen? Bit by bit, the data will be changing on the pins here. Yes or no? I don't want that effect to come on the shift register. So what I can do is, so I can disable the latch to start with. I can push the data into shift register. After pushing the complete data into the shift register, that is 8 bits are ready, then what I will do, whatever the data available in the shift register, I'll copy to the internal 8-bit latch. How do I copy it? The latch is enabled or disabled by using what is called a strobe signal. That is, whenever you want to copy the output of the shift register to the internal latch, I have to make strobe is equal to high. Whenever I make the strobe is equal to high, what will happen? The shift register output will be copied to what? Internal latch. After latching is done for 1 millisecond, I'll just make it off. Then, so whatever the data you push now, it will be available to the 7-segment display. Am I clear?
Yes, so it's to control the output basically. That's why we're using that.
Yeah, that the shifting action will not be produced in the 7-segment digit.
Okay.
The glittering, otherwise a bit by bit movement is there. No, that you will not notice on the digit, because once you shift it, once the data is ready, then I will copy the data, 8-bit data there.
Okay.